is double-stranded and circular. And replication of the DNA always begins at the same place. In E. coli, that is called OriC. At the beginning of DNA replication, strand separation occurs at OriC. So you get this little bubble. This bubble creates two places where DNA replication can occur, or two replication forks. Synthesis of DNA always occurs in the 5' to 3' direction, and so at one end of the fork we could imagine that replication's going in this direction. Because this strand is complementary and anti-parallel, synthesis would have to be occurring in the opposite direction at the other replication fork. But both strands of DNA have to be copied. And so at this replication fork, synthesis will be occurring in that direction, and at the other replication fork, it will be occurring in that direction. As synthesis proceeds, that bubble gets bigger and the forks move in different directions. This fork, replication fork, is moving in that direction. This replication fork is moving in the opposite direction. It's bidirectional. And we wind up with a DNA strand growing here continuously and here continuously. And then the complementary strand has to be synthesized little pieces at a time because it's moving. The synthesis is like this first piece was made here, the next one was here, the next one was here. Those little fragments have to be made in small pieces. Those are called Okazaki fragments. Eventually, the entire circle gets copied, and you have two double-stranded circular pieces of DNA.